The next topic that we want to cover is dilution. As we can see from the definition, it's the process of adding water to a solution to achieve a desired molarity. So you can think about it as watering something down. When you dilute something, you're basically watering it down. Often we use another vocabulary term associated with dilution, and that is the stock solution. And that's a concentrated solution that's routinely used for dilution to achieve a certain molarity. Think about it this way. I don't have every molarity of hydrochloric acid that I may ever want. So I buy a very concentrated stock solution. It's like 17 molar, and I keep it in the stock room on stock. And when I need a solution of hydrochloric acid, I take that highly concentrated version and I water it down to any concentration that I actually need. So you may do this at home with lemon juice, where you have a highly concentrated small bottle of lemon juice, and whenever you want to use it for baking or cooking, you water it down. That highly concentrated version is your stock solution. The guiding principle to do this work is that the moles of solute doesn't change in the solution. You're only adding water. So the moles before is equal to the moles after. And so since we know that moles is molarity times volume, right? Molarity is moles per liter. So moles is simply, if I cross multiply, molarity times liters or volume, then molarity times volume before is equal to molarity times volume after, where the 1 represents the solution before and the 2 after. This is our dilution equation. Let's give it a shot. How would you prepare 1 liter of 0.5 molar solution from each of the following? So you're preparing the 1 liter. That is your second volume. It's what you're preparing. And it's going to be 0.5 molar. So that is your second molarity. From each of the following, so you have this concentrated solution of H2SO4, sulfuric acid. And so the question you have to ask yourself is, well, how much of that highly concentrated stock solution do I need to then water down and make my new solution? So there's actually 3 parts to answering this type of question, and I am going to require you to answer it in 3 parts. So part 1 is to determine the amount of stock solution needed by using our equation. If I've went ahead and multiplied molarity times liters and then divided both by molarity, the units for molarity go away. I'm left with liters. I have 3 significant figures. Two significant figures in my problem, so 2 in my answer. So step 1 is to determine how much of the stock solution needed. Step 2 in solving this type of problem is to describe how much water should be added to the stock solution. So if we're making 1 of solution, but 0.028 liters of that is stock, then the amount of water that we're going to add is 1 minus the stock. And there's 2 ways you can say this. You can either say add 0.972 liters of water to 0.028 liters of stock. Or you could say add enough water to the 0.028 liters of stock to make 1 liter of solution. So those are two ways of describing it. Either one is fine for step 2 of the answer, but it's mandatory. And then step 3 would be to mix or stir. Because remember, the definition of a solution is homogeneous, right? So it's the same texture throughout. And so when you add the solute to the solvent, when you add extra water, make sure you stir it. That's a 3-part answer. Let's try one more. A solution was prepared by mixing 50 milliliters of 0.1 molar and 100 milliliters of 0.2 molar. Calculate the molarity of the final solution. This is a different type of problem. How should we approach it? We're trying to find the molarity of the final solution. That's moles per liter. Do we know either one of those things? We can know the liters just by adding together the 50 and the 100, right? So the number that goes in the denominator is clearly 150 milliliters, but I should change that to liters, correct? 123.15000 liters. So I do know the volume of the final solution. Do I know how many moles are in the final solution? I will have to find out how many moles is coming from each of the original solutions. So how can I use the given numbers to find that moles? Every time I'm relying on this idea that molarity is moles per liter. So moles then, if we cross multiply, is molarity times liters. So for the first solution, I had a 0.1 molarity and a 0.05000 liter solution. That's the first solution. For the second solution, I have a 0.2 molar. And remember, I'm changing milliliters to liters by moving the decimal to the left 3 times. I know the number of moles of each one of these. The sum of those, that's how many moles there are altogether when I mix the two. So let's do that. So the molarity for the overall solution is the number of moles of each of the individual solutions mixed together divided by the total number of liters. 0.1 molar. Remember, we can use uppercase M or we can use moles per liter for our units. I have 3 significant figures because every number, the smallest number rather that I used in my calculations, has 3 significant figures, and this is the answer. So each time we're either using the equation molarity is moles per liter, or we may, if it's a dilution problem, if it's specifically asking us about watering something down, we may be using the M1V1, M2V2 equation.